As we have seen, primary radar works on the echo principle and relies on the reception of a reflected pulse. However, secondary radar works on the principle of interrogation and response, and hence the interrogator relies on a reply being transmitted. Secondary surveillance radar, abbreviated to SSR, is one type of secondary radar. DME is another, which we have looked at in its own lesson. Air traffic control use both primary radar and SSR to track the progress of aircraft. Primary radar provides position information since it is more accurate than SSR. But the main advantage of SSR is that it can provide positive individual aircraft identification. In addition, SSR requires less power, since it does not rely on reflected pulses. The SSR ground equipment is referred to as the interrogator. The airborne equipment is known as the transponder. To resolve the identification problem, air traffic control allocates a 4-digit code, which the pilot sets on the transponder. When interrogated, the transponder automatically replies with the 4-digit code in the form of pulses. Hence, both transmissions are one-way only, from transmitter to receiver. The radar display can now indicate not only the aircraft's position in range and bearing, but also the 4-digit code, known as squawk, which can be associated with an aircraft call sign and hence its identity. In addition, height information and track history can be displayed. The SSR antenna, usually oblong in shape, is, in most cases, mounted on top of the primary radar, so that the rotation of both antennae is synchronized. The ground-based interrogator transmits on 1030 and receives on 1090 MHz. The airborne transponder does the reverse. After a 50 microsecond delay to allow for signal processing, it transmits on 1090 and receives on 1030 MHz. Both of these frequencies are within the UHF band, and so the maximum theoretical range of the system is limited to line of sight. The SSR ground antenna transmits a narrow beam in the horizontal plane, which scans through 360 degrees, whilst the aircraft transmits omnidirectionally. The ground interrogator transmits a predetermined series of interrogation pulses on the carrier frequency of 1030 MHz. The two main interrogation modes are Mode Alpha and Mode Charlie. Mode Sierra is a new system, which will eventually supersede Modes Alpha and Charlie, but we will look at it in the next lesson. Of the current modes, Mode Alpha provides the identification function, bearing and range, whilst Mode Charlie provides height information. The interrogation comprises a series of pulses. The mode of interrogation is dictated by the spacing between the first and third pulses, P1 and P3. For a Mode Alpha interrogation, the spacing is 8 microseconds. For Mode Charlie, the spacing is 21 microseconds. This enables the aircraft to reply with the correct information. The design of SSR antennae, usually referred to as slotted arrays, tends to promote the production of side lobes, wasted energy that spills out of the sides of the aerial. To prevent aircraft from replying to interrogations in the side lobes, which would be displayed on an incorrect bearing, An additional pulse, P2, is transmitted 2 microseconds after P1. Unlike P1 and P3, which are only transmitted in the direction that the antenna is pointing, P2 is radiated in all directions. It is arranged that the signal strength of P2 just exceeds the maximum possible strength of any of the side lobes. This means that 2 SSR aerials are needed, in addition to the primary radar aerial. A rotating one gives direction, and a fixed one is used for side lobe suppression. The transponder, before replying to an interrogation, compares the strength of P2 to the strength of P1 and P3. If the aircraft is in a side lobe, P2 will always be stronger, and the reply will be inhibited. If the aircraft is in the main beam, P1 and P3 will be stronger than P2, and the transponder will reply. P2 is therefore referred to as the side lobe suppression pulse. On receiving a valid interrogation, the aircraft transponder transmits 2 framing pulses, F1 and F2, which are 20.3 microseconds apart. Between the framing pulses, there are up to 12 usable information pulses, with a permutation total of 4,096 codes. The letters A, B, C, and D refer to the 4 digits displayed in the transponder windows. Each letter can have up to 3 pulses with a value of either 1, 2, or 4, which, when added, total 7. 7 is the highest number used in the transponder. So, all 12 pulses will only be used if the 4 numbers displayed are 7, 7, 7, 7. That is, 1, 2, and 4 are used 4 times. If the transponder number required was 5432, the number 5 would be made up of 2 pulses, A1 and A4. The 4 would be 1 pulse, B4. The 3 would be made up of C2 and C1, and the 2 would be 1 pulse, D2. This means that 6 information pulses would be used, and the other 6 would be suppressed. To assist the controller in identifying an aircraft, the controller may ask the pilot to squawk ident. The pilot presses the ident button on the transponder, and a further pulse, called a special position identification pulse, is transmitted 4.35 microseconds after the second frame pulse. This pulse transmits continuously for 20 seconds once the button is depressed, and the indication to the radar controller when this happens is that a ring appears on the screen, encircling the primary return. The ground station interrogates simultaneously in mode Alpha and mode Charlie. Given that an aircraft will be allocated an ATC squawk, the pilot will have selected those numbers in the corresponding windows on the transponder. When interrogated, the transponder produces a series of reply pulses. When the ground station receives the mode Alpha code, it can calculate the aircraft's bearing from the ground station, but it does not know the height of the aircraft. To obtain the height of the aircraft, the ground station sends a mode Charlie interrogation, which we have seen means that pulses P1 and P3 are 21 microseconds apart. To operate in mode Charlie, the transponder must be set to Alt on the transponder function selector. The aircraft replies with 2 framing pulses, and up to 12 pulses in between. The reply is in an ICAO-determined code that corresponds to its height, referenced to 1013 hectopascals, regardless of the pressure setting on the altimeter and the code selected on the transponder. The mode Charlie code is determined by an encoder, which is mechanically actuated by the altimeter's aneroid capsule, and is thus independent of the altimeter's pressure setting. It is accurate to within 50 feet. The radar screen displays the aircraft's height to the nearest 100 feet. If, when asked to verify the aircraft height, the altimeter reading is more than 300 feet different from the mode Charlie reading, the pilot will be instructed to switch off mode Charlie, go to mode Alpha, and display 0000 on the transponder. In the UK and most of Europe, the limit is 200 feet. If the operator is not satisfied with the transponder reply, he may ask the pilot to recycle. That is, reset the numbers or set different numbers. Some codes are reserved internationally for special purposes. The code 7700 indicates an emergency condition. However, if the aircraft is already transmitting a discrete code and receiving an air traffic service, the former code may be retained at the discretion of either the pilot or the controller. 7600 indicates a radio failure. 7500 indicates a hijack. In the second table, which shows conspicuity codes, 2000 is used when the aircraft enters UK airspace and it has not previously been asked by an ATC unit to operate the transponder. In the UK, a conspicuity code has to be used. The code 7000 and mode Charlie must be selected above flight level 100, except when given a different setting by air traffic control or one of the special codes is used. 7000 and mode Charlie should be used below flight level 100, unless the same exceptions apply. SSR has the following advantages over primary radar. It requires much less transmitting power to provide coverage up to 200 nautical miles. It is not dependent upon an aircraft's echoing area or aspect. It gives clutter-free responses, as it does not rely on returning reflected pulses. The target is positively identified, and its code and call sign can be displayed. An aircraft's track history, speed and destination may also be displayed. If the aircraft has an emergency, has lost radio communications, or is being hijacked, this fact can be displayed by special codes. SSR also has several disadvantages. Only 4,096 separate codes are available, and given the number of aircraft in current and projected use, it is not enough. SSR is subject to garbling. This is caused by overlapping replies from 2 or more transponders on nearly the same bearing from the ground station, and within a distance of 1.7 nautical miles from each other. SSR is also subject to fruiting. This is interference at one interrogator caused by replies from a transponder responding to another interrogator. As a result of these disadvantages, a new system called Mode S has been introduced, and we will look at this in the next lesson. In this lesson, we have seen that secondary radar works on the principle of interrogation and response. The interrogator transmits on 1030 MHz, and the transponder transmits on 1090 MHz. There is a 50 microsecond delay at the transponder, so remember to allow for this if you are asked to do any range calculations. 2 aerials are required, a rotating one for direction and a fixed one for side lobe suppression. Mode alpha is a discrete code allocated by air traffic control. 4096 codes are available. There is an 8 microsecond spacing between the P1 and P3 pulses. Mode Charlie is for altitude reporting. It is based on 1013 hectopascals, whatever altimeter setting the pilot is actually using. It is accurate to within 50 feet. It is displayed to the nearest 100 feet. There is a 21 microsecond spacing between the P1 and P3 pulses. The squawk ident pulse is transmitted 4.35 microseconds after the second framing pulse for 20 seconds. A mode alpha squawk of 2000 means that the aircraft is entering UK or European airspace and requires an IFR service. 7500 indicates unlawful interference or hijack. 7600 indicates radio failure. 7700 is an emergency. It means Mayday. It should not be used for a pan situation. One problem associated with SSR is garbling. It occurs if 2 transponding aircraft are within 1.7 nautical miles of each other. The other is fruiting. This is caused by unrequested replies triggered by a second ground interrogator. This completes the lesson on SSR. The next lesson shows how Mode Sierra overcomes some of these limitations.